Hello class 11 science. Today we are going to see about the electronic configurations that you have committed mistakes while writing the electronic configurations, most of you. Today I am giving you the solutions of assignment 17, 18 and 19 where I have solved and written the correct electronic configuration of the elements starting with atomic number 1 till 30. Okay, so all of you please go through it, do the corrections wherever is required. Okay, and in that the two electronic configurations that was written are incorrect, most of you. That I am going to explain what is the reason and why it is wrong. Okay, exceptional configuration of chromium and copper. So if you have seen, or if you have written the configuration of chromium and copper, you'll notice that these two elements, copper and chromium, show deviation from the normal electronic configuration. Okay, say for example, the electronic configurations for chromium with atomic number 24, you have written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. This is according to our normal writing of electronic configuration, the order it follows. And for copper with atomic number 29, we have written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. So these two electronic configurations you have written, okay, but both of them are incorrect. Okay, however, the actual configuration for chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay, not 4s2, 3d4, but it is 4s1, 3d5. Similarly, for copper, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10, not 4s2, 3d9. Okay, now the explanation for this, why the actual configuration for chromium and copper is like this because the half filled and fully filled configurations, that is d5 and d10, or in case of f orbital, if it is f7 or f14, they have got lower energy and more stable. So while writing the electronic configuration, we will also keep in mind the stability of the electronic configuration. So if you see in this electronic configuration, so it is 4s2, 3d4. So if d orbital can have 5 half filled, that is because the maximum capacity of d orbital is 10. If it has got 5 electrons, then it will be stable, and if it has got 10 electrons, it will be more stable. Okay, so that's why in order to become more stable, one of the 4s electrons goes into 3d electrons, so that 3d orbitals have half filled or fully filled configurations in chromium and copper respectively. So what will happen, from 4s, one electron from 4s will go to the d electrons to make it half filled or full filled orbitals, because half filled and full filled orbitals are very stable. Okay, now today we are going to see how to write down the electronic configuration of ions. In our previous classes, we have seen that how we'll write down the electronic configurations of neutral atoms. How we'll write down the electronic configuration of neutral atoms. So today we'll see the writing of electronic configuration of ions, cations and anions. Say for example, if you take a sodium ion Na plus, which has got a atomic number 11. Okay, now first thing that you need to find it out is number of electrons. What is the total number of electrons present? So since atomic number is 11, number of proton is also 11, but since there is a positive charge, that means one electron is getting lost. So the number of electron will be 11 minus 1, that will be 10. Okay, next we have got electronic configurations electronic configurations, we can write for 10 electron as 1s2 2s2 2p6 10 electrons. Similarly for Fe2 plus having atomic number 26, since we have got two positive charge, we'll subtract these two electron from the atomic number to get the total number of electrons. So 26 minus 2 will give you 24. Now for iron, if you have seen and if you have written the electronic configuration, we have written as 1s2 2s2 2p6 3s2 3p6 3d6 4s2, and some of you have also written as 4s2 first then 3d6. Both are correct. Okay, you can write either 4s first and 3d after that. Okay, so in this case, when the electron gets lost, it lost from the 4s electrons. Okay, so the two electrons from 4s will get lost. So the for Fe2 plus, the electronic configuration will become as 1s2 2s2 2p6 3s2 3p6 3d6. Okay, next for negative ions, that is anion, atomic number we have got 9. So we'll find number of electrons. So in case of when you have got a negative charge, we need to add the electrons. When there is a positive charge, we need to subtract. When there is a negative charge, we need to add. So 9 plus 1 10 electrons. So we can write down the electronic configuration as 1s2 2s2 2p6. Fine. So this is how we can write down the electronic configurations of ions. Okay, in a similar way, today's assignment, okay, write the electronic configuration of the following ions. First one is Mg2 plus, atomic number is 12. Calcium 2 plus, atomic number is 20. Third one Fe3 plus, that is ferric ion, having atomic number 26. Fourth one is chromium 2 plus, having atomic number 24. Manganese 4 plus, having atomic number 25. O2 minus, oxygen ion, having atomic number 8. Nitrogen ion, having atomic number 7. Sulfide ion, having atomic number 16. Copper ion, having atomic number 29. And zinc ion, having atomic number 30. So complete this assignment, write down the electronic configuration as I have explained, and send it in my mail.